right, let's take a look for our warm-up for yesterday. Evaluate each expression. What does evaluate mean? Solve each expression if m equals 2, n equals 6, and p equals -4. All right, and on the board, when the directions were on the board for doing your warm-up, what did it say to do? Show the substitution. Okay, so if I were to look at number 1, 3m, does that make that 32? 32 plus 4, -44? Is that what that makes that? No. Oh, okay. Somebody help me out. What should it look like? Noelle? 3 times 2 plus 4 plus -4. Yes. So when a number is right in front of a variable, this is called a coefficient. This coefficient tells you how many of these m's you have. And if m is 2, that's telling me I have 3 2's. Well, 3 2's is how many? 6. 6 plus 4 times -4? -16. Or I could have wrote it as 6 minus 16. All right, the signs are different, so do I add or subtract? Subtract 6 plus -16. -10 is our answer. So you should either know that that means you subtract their absolute values. 16 minus 6 is 10. And then you take the sign of the integer with the greatest absolute value, which is -16. Or you could go to +6 on the number line, and then what does it mean to do? Go back how many places? 16. So if you were at +6 on the number line and you made 16 jumps in the negative direction, you would land at -10. What's one more way I could solve that? So I could know the rule. I could use a number line. What's the third way that I show? Counters, right? 6 positive counters, 16 negative counters, cross off 0 pairs, and I'm going to be left with 10 negative counters. You have to know how to do that some way without a calculator. If it was me, I would have tried this section without a calculator as well. All right, n squared plus -5. So what is n? 6. 6 squared plus -5. What is 6 squared? Is that 12? It's 36. That means 6 times 6. So 36 plus -5, or I could think about that as -5. What is my answer? 31. Positive or negative? You start at positive 36, and then you go 5 in the negative. Does that put me all the way over at -31? No, it doesn't put me even anywhere near the 0. If I was at positive 36 and went back 5 places, that leaves me at positive 31. Everybody good with that? 3. 6p cubed, or 6 times p to the 3rd power. So 6, and what is p? It is times -4 to the 3rd power. Let's do that differently, because if I put that in parentheses, it looks like that negative is in the parentheses, and it's not. So we're going to say 6 times -4 to the 3rd power. What am I going to do first? Am I going to do the multiplying or the exponent? The exponent. So what is what is 4 to the 3rd power? And normally we would grab the sign in front of it, but that's only if it looked like this. Then the negative would go with it. Here the negative does not go with it. It's in front of it. So it's 4 to the 3rd power, which means 4 times 4 times 4. 4 times 4 is 16, and 16 times 4, 64. So 6 times negative 64. Because I did have to still pick up that negative. 64 times 6. 384. Positive or negative? Negative 384. Oh, that one was fun, right? I thought so. All right. Last one. Anybody tell me how you would read this one? Yes, very good. Divide by negative 2. But p minus 2 divided by negative 2. So I really have to, let's show the substitution and then try to figure out what we're going to do first. P is negative 4. So I have subtract and I have divide. Does anybody know what we're going to do first? You have to do the top first, right? Even though in order of operations, divide comes first, we still have to work top to bottom. If there was division up here, we would do it first. Negative 4 minus 2. Anybody know where we're going to end up? Negative 6. If you're at negative 4 and you go 2 more in the negative direction, you're going to land at negative 6. Or if I have 4 negatives and then I add 2 more negatives to it, I still have, it's negative 6. Negative 6 divided by negative 2, positive 3. You really should be able to do all of those problems without a calculator. I would start practicing those now. All right, Wednesday, Orville and Wilbur Wright made the first airplane flights in 1903. Wilbur's flight was, or you could also think of that as the word is, but it's was, 364 feet. This was 120 feet longer than Orville's flight. Write and solve an equation to find the length of Orville's flight. Anybody have the equation first? I saw lots of you had the right answer. I'm not sure I saw a lot of people have an equation. And that is really the 7th grade work, not just finding the answer, but writing an equation. So where it says was or is, I'm going to have an equal sign. 364 feet. Now, 120 feet longer than Orville's flight. Find the length of Orville's flight. So Orville's flight plus 120. Should I use an O for Orville? I should. In math, what does it look like? It looks like a 0. Let's make it a B. Let's make it a B because our variable can be whatever we want. So Orville's flight plus 120 equals 364. Now what? Yep, subtract 120 from both sides. What do we get? 442. 244 feet is the length of Orville's flight. Does that make sense? But the way you were supposed to do it was writing an equation. Did you have an equation that you started with? Then you did not do it the 7th grade way. Okay, so the whole point is being able to write the equation. Actually, this is really just a 6th grade problem, people. 1-step equations are 6th grade problems. 2 steps are 7th grade. And this was just a straight up 1-step equation. Okay. 2, a pair of boots cost $159, but the pair is on sale today, 25% off. How much money will you save if you buy the boots today? How much will you pay? Anybody know how much money you're going to save? And you're going to be able to tell me how much. Camden? $39.75. How did you do that? Yep, that's one way to do it. 25% times $159. And so we're going to save. There are some people that would say that's how much we're going to pay. But we didn't save almost all of it. We just saved a little bit. So how much are we going to pay? How are we going to find that? So we're going to subtract $159 minus $39.75. And so how much will you pay? $119.25. You've got to know which is which. You cannot have those reversed or they would both be wrong. A shark can swim at an average speed of 25 miles per hour. That is the rate. At this rate, how far can a shark swim in 2.4 hours? So if I asked you what the constant of proportionality from that problem is, what would you say? What's the constant of proportionality? You should know that. Come on. Somebody be brave. Constant of proportionality is the same thing as what? Unit rate. And so that's how long, in this case, how many miles in 1 hour. So what would our constant proportionality be? 25. You should know that and be able to pick up on that immediately. If you see 25 miles per hour, you should know that's the constant proportionality, 25. What would be the equation that matched that constant of proportionality? Come on, bonus points. What would be the equation for that constant of proportionality? Riley, do you know? You're going to have two variables in there. Yep, but normally we're going to see it like this. Y equals 25x. That would be your equation for that constant of proportionality. Every time I multiplied it by the hours, I would see the distance. All right, so how are we going to solve this problem? At this rate, how far can the shark swim in 2.4 hours? Anybody have a way that we can solve this? What did you do, Alexis? You could. Normally, if it's per hour, you would normally put the 1 in the bottom. But if you put it in the top, you would have to put the 2.4 over there. So 25 miles in 1 hour is how many miles in 2.4 hours. So as long as your hours are both in the same place. Now what do we need to do? Cross multiply. 25 times 2.4. And we get 60. So I would get 60, and then over here 60. What number times 1 is 60? 60. So at this rate, how far can the shark swim? The shark can swim 60 miles in 2.4 hours. Everybody good with that? Do you see how everything that we've just done is a review from this year? Yes, none of this was new. If you were having a hard time with it, you need to start using a journal when you're doing your warm-up. We're going to do these kinds of milestones reviews for the next few weeks. Okay, put your warm-up to the side. Let's look at our notes for today. You should have picked up all of the papers over by the sign-in table. Were these mine? I want to start with this paper right here. right, so when we're working with statistics, if you are going to take a survey, you can either survey a sample of the population or the entire population. So if this circle represents the entire population, that's all of the people in the population. If you talk to some of them, that is called a sample. So, just part of an entire population, if you take a survey, you can survey just a sample of the entire population. Okay? But you have to make sure that you do that in a way that is fair and represents all of the people in this population. So in math, you can take a survey from a sample and then apply the data to make a prediction about the entire population. You must make sure that your survey is a fair representation of the population or that it is unbiased. That is the word that you need to know. When it is fair, it is unbiased. All right? So, your population here, if our population was all of the students at Ringgold Middle School, can I take a sample instead of talking to all 1,000 kids in the school? Yes. But when I do that, I have to make sure it's a fair representation. That I talk to 6th graders, 7th graders, 8th graders. That I talk to boys and girls. I talk to athletes and non-athletes. Like, you have got to make sure that it is a fair representation of the entire population. Okay? Otherwise, it is biased, and that is bad. Okay? So, we're going to look over here at a couple of ways to make sure that it is a fair representation. So, if I'm going to take a survey, the first thing I think is, am I going to take a sample? Am I going to survey a sample of the population, or am I going to talk to the whole population? If I talk to the whole population, that is actually a specific survey called a census. A census is when you talk to or survey an entire population. And whenever you do that, that's unbiased and that is valid, right? So in 2020, we are at a place in our country where we are doing a census. Every 10 years in this country, there is a survey that is sent out to every family in the country. You have to fill out like a booklet of questions. Normally one person per family fills it out. So like I'll get that probably sometime this summer and I'll fill it out. And that when I fill it out, it represents me, Mr. Miller, and both of our 2 kids, right? They make sure everyone in the country is talked to. Homeless people are talked to. People in the hospital, that someone has answered questions for them. You might see signs as you're driving down the street like, we're hiring census takers. Because they make sure that every family in the country, someone has answered that, and if they haven't, they send people out to go looking for them so they can help them complete the census. That happens every 10 years in this country. That's where a lot of our data comes from, about who owns homes and that kind of thing. Questions about that? So if you take a census, that's surveying an entire population, that is always unbiased and that's always valid. So that's one way to make sure you do it. Is that always easy to do a census? No. So sometimes you're going to say, I'm going to take a sample of the population. So we're going to look at the different ways that we can either make sure it is unbiased or biased. So if I collect a sample, the data was collected by a convenience sample, that's biased and it's not valid. So a convenience sample means, again, if I'm saying the entire population is Ringgold Middle School, if I go to the cafeteria during 6th grade lunch and ask a few people at the first table a question, is that a valid way to take a survey? It is not, because that is a convenient sample. That was at my convenience. I didn't go out of my way. I didn't go out looking for certain groups of people. I went to one place, talked to the people that it was easiest to talk to, and then I just called it a day. So if you are doing something that is convenient for you, but you didn't make sure it was representative, that is biased and not valid. You are responsible for knowing these different ways to take a survey. I see that some of you look like you're bored and you're checked out. Y'all, you got to know this. All right. The data was collected by a voluntary response sample. That might be that, say you're watching TV on, I don't know, Freeform, and they say, if you want more shows like the one you're watching, call this 800 number. Well, that's called a voluntary response sample. The people that call in that say, hey, I like this show, give me more, they're watching the show because they like it. And they're going to call in because they want more. That's called a voluntary response sample. When you are asking people to volunteer to take a survey, these people normally have a strong opinion for or against something. And so that is biased and it is not valid. So how are some of the ways that we can get unbiased and valid results? Well, the data was collected by a simple random sample. That means if I'm taking a survey for the population of Ringgold Middle School, I go down the 6th grade hall and find some people, boys and girls, to talk to. I go down the 7th grade hall, I go down the 8th grade hall, and I just randomly talk to people. But I make sure that I do it all day long and that I talk to enough people that it represents the entire population. Or I could do a systematic random sample. That means I put a system in place. Maybe I stand by the doors where people come in and I talk to every 5th person that comes in. But can I just talk to the car riders? No, because what if it's a survey about buses? Are the car riders going to be good people to talk to? No, I probably need to talk to them. They're usually people that don't really like to ride the bus. But then I probably also need to go down to where the bus is let out and talk to maybe every 5th person that gets off the bus. So a systematic random sample means that I'm going out of my way. I have a system in place, maybe drawing names from a hat, or that there is a system in place and that I'm still talking to random people. Does that make sense? You are responsible for understanding what all 4 of those terms mean. So, and then there's a note here you might want to highlight. Biased is bad because it does not fairly represent the entire population. Unbiased is good because it represents the entire population. You have to know that biased is not valid, unbiased is valid, that you can use and trust the data that you get. All right, put that one to the side. Let's look at this one that talks about samples and populations. So we're going to actually try to identify the difference between a sample and a population. So here's just some more notes. A population is an entire group of people or objects. A sample is part of that population. Those are words that you need to know. You can use a sample to make a conclusion about a population, but you can only do so if your sample is collected using valid or unbiased methods. Okay? So identify the population and the sample. So here's 2 examples. The students in a science class would be a sample. The population would be all of the students in a school. Here, all the sneakers in a store, the whole group is the population. 5 pairs of yellow sneakers in a store would be a sample. So you've got to be able to pick out which one's the entire population and which one is a sample. So let's look at number 1. We have 75 dimes. And we have all dimes in circulation. Which one's the population and which one's the sample? Autumn? The what? Yep. This is the sample. All dimes in circulation is the entire population. Let's look at the next one. People in the United States and a selection of shoppers from different states. Summer? Yep. Very good. All the people in the United States is the population. A selection of shoppers from different states is the sample. Let's look at the last one. The files on a computer, the music files on a computer. Anna? Very good. All right, so you need to be able to identify the sample from the population, and it seems like you all are pretty good at that. We okay with that? Okay, let's put those to the side. We're going to put everything in our journal all at once. Let's get through this learning task. Is it valid? A survey is a method of collecting information. These pieces of information, numbers and facts, are called data. Okay? So, describe your class survey. In the space below, compile the data collected by your classmates. So, we don't really have time. In years past, we would have gone through and done this. We're just going to use some old data and go from there. So, what color is your hair? So, in this sample class, 13 people had brown hair. 3 people had blonde. None had red. And 4 had black. You're just filling in this, and then we're going to do some work with these numbers. 13, 3, 0, and 4. Do you carry a cell phone? In this class, 17 people said yes. 3 said no. About how many text messages do you send in a day? 0 to 20, 8 people responded. 21 to 40 was 5. More than 40 a day was 7 people. About how much time do you spend on homework? 0 to 15 minutes was 2 people in this class. 16 to 30 was 13. 31 to 45 was 2. 46 to 60 was 3. And more than an hour was 0 people. Homework clearly was not our focus with this class. Okay. What month were you born? So January to March, there were 3 people. April to June, there were 5. July to September, there were 6. And October to December, there were 6. So that was our data. If we had taken a survey from this class, this was the data that we got. Using the survey results, discuss the following vocabulary. What is the population of your survey? So if this was a single class that answered all of these questions, at this school, what would be the population? Ringgold Middle School, 7th grade students. So 7th grade students at Ringgold Middle School. Why did it specifically have to be, why was the population specifically 7th grade students? Because the class that was surveyed was only 7th grade students. So it was a random sampling of just 7th grade students. So the population could only be all of the 7th grade students. It could not be all of the students at Ringgold Middle School because there were no 6th graders and no 8th graders. Did your class perform a census or a survey? Was it a census or a survey? A census talks to the entire population. It was a survey, right? It was just a survey. How would you record your results from question 1 as a piece of data? So if you were walking around and you were going to ask people questions, what might be a way that you would record that? What we said last year was probably a tally chart where you walk around and you have the different columns. So we decided a tally chart would be most effective. How would you describe your results from question 2 as a parameter for the population? That kind of means, how would you use this information from 2? Do you carry a cell phone? 17 said yes, and 3 said no. How would you describe that as a parameter for the population? So parameter means to create a statement about most people in the population. So think about that definition for parameter and look at number 2 and see if you can create a statement about most 7th grade students at Ringgold Middle School. Are you looking at number 2? The question? Can you make a statement about most 7th grade students at Ringgold Middle School from that data? Anna? Yes, that would be what you would say. The evidence is overwhelming. 17 out of 3 have cell phones. So the statement you could make about 7th graders is most carry a cell phone. From that data, could we actually make a prediction about how many we think? If we knew how many 7th graders there were? So what's the probability that a 7th grader in this class carries a cell phone? 17 out of how many people were surveyed? 20. Right? There were 20 people in the class. 17 carried a cell phone. Now let's say there's 300 kids in 7th grade. Could I make a prediction about the number? How would I do that? I would say 17 out of 20 equals how many out of 300? So phone. This was a total, and this was the total. So if this was the sample, 17 out of 20, then how many out of the population? Okay, so we cross-multiplied by 17 and then divided by 20, and we got what? 255. That could be our prediction, right? I predict 255 7th graders carry a cell phone. Questions? Okay, let's go on. Let's look at some other types of questions about different surveys. For each problem below, answer the questions in regard to population, samples, and surveys. So, after the 2000 census, the United States Census Bureau reported that 7.4% of Georgia residents were between the ages of 10 and 14. Can you have a decimal like that for a percent? 7.4%? What is that between? That's between 7% and 8%. So you can have a decimal for a percent. Was a parameter or a statistic reported? Explain your reasoning. So remember, down here, a parameter is a statement about most people in the population. A statistic is an actual percent. So would this be a statistics or a parameter? A statistic or a parameter? That 7.4% of Georgia residents were between ages of 10 and 14. What is that going to be? A statistic, because it was reported as a specific percent. What is the population for this survey? Well, we have to go back up here and we look. The population is what? Every person living in Georgia. The manager of Mill Creek Mall wants to know the mean age, that means the average age of people who shop at the mall, and the stores in which they typically shop. He hires Barker Market Research Company to collect the data. Dennis works for Barker Market Research Company and has been put in charge of collecting data for the Mill Creek Mall. Dennis decides to interview 100 people one Saturday because it's the mall's busiest shopping day. Is this a sample or a census if he surveys people on a Saturday morning? What? It's a sample, right? Not the entire population of everybody that shops at the mall. It's a sample. What is the population for this survey? So who do these people represent? All people that shop at Mill Creek Mall? Do you think the sample size is appropriate for the survey? Do you think only 100 people on a Saturday morning is going to represent the entire population? I think it's too small. If you think there are thousands and thousands of people that shop there, 100 is not enough. I really think there needed to be more data. I also think that maybe it's not valid because it was a convenient sample. He only went on a Saturday morning and asked 100 shoppers at that time. That feels like that was probably a convenient sample. All right, so let's look at the other page that's got some problems for us to practice with. Biased or unbiased. We're going to read some situations and we're going to make some decisions about whether it was biased or unbiased and why or why not. All right, so there are 3 key things to look for when determining if a survey is biased. And biased is what? Good or bad? Biased is bad. Is the survey voluntary? So you're looking to see if it's voluntary. Voluntary surveys normally only get people to participate who feel strongly about the survey topic. Therefore, it would be biased. Does the survey exclude any group? If your survey only includes a certain section or group and leaves out other participants, it is also biased or bad. Is the sample size appropriate? If you want to make inferences about an entire city, for example, yet only ask people on one street, the sample size is too small and not representative of people in other areas of the city. So it would be biased. So what I would like you to do is I would like you to turn to that flow chart that has, I don't have mine in my book yet, that has the different ways to tell if it's biased or unbiased. You need to have that out. These are the things we're going to look at. They're all going to be a sample, but we need to look and see if they're biased or unbiased and see if we can find one of these 4 reasons that will fit. Okay? So you're looking at that flow chart. ABC Family is a television channel that targets families and young adults to view their station. ABC Family regularly posts online polls, questions to their website. In 2010, ABC Family polled their viewers to ask about airing rated R movies after 8 p.m. on their channel. Almost 200,000 people responded, and 85% of them disagreed with airing rated R movies. So, is this biased or unbiased, and why? Do you think this was an appropriate way to take this survey? Anna? Biased. So I can look and think, was it a convenient sample or a voluntary response sample? Voluntary response. So it's biased because it was a voluntary response. Oh, I spelled that wrong. Hold on. It was biased because it was a voluntary response sample. What part of that lets you know it was a voluntary response sample? They had online poll questions. So only people that had strong feelings for or against would have taken their time to get online to answer the question. All right, here we go. Next one. Mrs. Jones wants to know how the 5th grade feels about recess time. Mrs. Jones probably should have already known, but Mrs. Jones labels every student in the 5th grade with a number. She then draws 50 numbers out of a hat and surveys these students. Mrs. Jones determines that the 5th graders would like more recess time than they currently have. Shocker. All right, what do you think? Biased or unbiased, and why? Yes. Unbiased, and why? So if we look down the unbiased, did she do a simple random sample or a systematic random sample? Systematic, right? What let me know it was systematic? Yes, putting them in a hat. That was systematic. So unbiased because it was a systematic. Two more. The city of Smallville wants to know how its citizens feel about a new industrial park in town. Surveyors stand in the Smallville Mall from 8 a.m. to 11 a.m. on a Tuesday morning and ask people their opinion. 80% of the surveyed people said they disagree with the new industrial park. Yes? That's unbiased. So they did a simple random sample or a systematic random sample. I think it's going to be biased because I think it was a convenient sample. They went to one place on a Tuesday morning for 3 hours. And if you can talk to people at the mall from 8 a.m. to 11 a.m., they are not the people that are looking for a new industrial park. New industrial parks, those are probably retired people or stay-at-home moms. Neither one of them want a new industrial park. You probably are going to need to talk to people that need a job or want to work or have a business they want to open. So it is biased because it was a convenient sample. Last one. The National Rifle Association, the NRA, took a poll on their website, www.nra.com, and asked the question, do you agree with the Second Amendment, the right to bear arms? 98% of the people surveyed said yes, and 2% said no. Biased or unbiased? Think about your flow chart and the way they collected their data, and see if you can back up your answer. Autumn. Biased. Why is it biased? It was, yes, it was a voluntary response sample. All right, so after we put this in our journal, we can work on the skills practice. If we don't get it finished today, we'll work on it tomorrow. But you're doing the same thing as we just did on this paper. You're reading the situation and then deciding if it is biased or unbiased and telling why. But let's go ahead and put these in our journal. So I need to cut this out. I'm going to cut these two apart. And I'm going to cut these two apart. All right, so it looks like the last thing we glued in was on page 101. So it looks like we're going to use the next 5 pages, or 5 or 6. So 102, 103, 104, 105, and 106, and 107. Don't spend time trying to cut out all those corners. Just cut your paper in half. We don't have time for all of that decorative cutting. Just cut it in half. Okay. So I'm going to put these two on 102 and 103. I like that you all have not stopped doing your decorative cutting. It's almost the end of class. Just cut the papers in half. All right, 104 and 105 is going to be our learning task that looks like that. 104 and 105. Skip 106 and leave it blank for a practice problem, and put 107 right here. Put this one on 107. Okay. All right. And then get table of contents up to date. So that was 102 to 107. Surveys. We're going to call that surveys 102 to 107 in your journal. When you get done, start working on your skills practice. And then we can take this one and put it right here on 106. Okay. Everybody good? What do we need? Table of contents?